Hey, hi everyone, welcome back to this video series on Windows Server 2016. Packet tracing with Wireshark or Netmon. Eventually, you might run into the need to look a little deeper into your network packets. Now we're entering territory where your network team may also be involved. If you are familiar with these tools, you may be able to solve the problem before needing to make that phone call for assistance. Make use of command line tools for checking on the status of servers and services is very useful, but occasionally it may not be enough. For example, you have a client application that is not connected to the application server, but you don't know why. Things like ping and even telnet might be able to connect successfully, indicating that network routing is set up properly, yet the application fails to connect when it opens. If the application's own event logs are not helpful to troubleshoot what is going on, you might want to take a deeper look inside the network packets that the application is trying to push forward the server. This is where the tools Wireshark and Netmon come in handy. Both are free and easily downloadable, and they both perform basically the same functions. They are designed to capture network traffic as it leaves from or arrives to a system, and they capture the information that is inside the packets themselves so that you can take a deeper look into what is going on. In our example of the application that cannot connect, you could run one of these tools on both the client computer to watch the outgoing traffic and on the application server to watch for the incoming traffic from the client. Each tool has quite a bit of individual functionality, and we don't have the space to cover all of it here. So I will leave you with the links to get these tools so that you can test them out for yourself. Wireshark, www.wireshark.org/download.html, Netmon, https microsoft.com /enus/download/details.axpx ID equals 4865. TCPView. The tools that we have discussed so far are great and can be used on a daily basis for poking and prodding individual resources that you want to test, but sometimes there are situations where you need to step back and figure out what it is you are looking for in the first place. Maybe you're working with an application on a computer and are not sure what server it is talking to, or perhaps you suspect a machine of having a virus and trying to phone home to somewhere on the internet, and you would like to identify the location that it is trying to talk to or the process that is making the call. In these situations, it would be helpful if there was a tool that you could launch on the local computer which tells you all of the network traffic streams that are active on this computer or server. This is exactly what TCPView does. TCPView is a tool originally created by sysinternals. You must have heard of some of their other tools like procmon and filemon. Running TCPView on a machine displays all of the active TCP and UDP connections happening on that computer in real time. Also important is the fact that you do not need to install anything to make TCPView work. It is a standalone executable, making it extremely easy to use and clear off a machine when you are finished with it. You can download TCPView at https://technet.microsoft.com/ens/sysinternals/tcpview.aspx. Simply copy the file onto a computer or server that you want to monitor and double click on it. Here is a screenshot of the TCPView interface running on my local computer, showing all of the connections that Windows and my applications are currently making. You can pause this output to take a closer look, and you can also set filters to pare down the data and find what you're really looking for. Filters to get rid of the noise, so to speak, and enable you to look more closely at a particular destination or a specific process ID. Building a routing table. When you hear the term routing table, it is easy to pass that off as something the network guys need to deal with, something that is configured within the network routers and firewalls. It doesn't apply to the server admins, right? Network servers together has been made pretty easy for us by only requiring an IP address, subnet mask, and default gateway, and we can instantly communicate with everything inside the rest of the network. While there is indeed a lot of networking magic going on under the hood of the traffic that has been provided to us by networking equipment and networking administrators, it is important to understand how routing inside Windows works, because there will be some cases when you need to modify or build out a routing table on a Windows server itself. Multi-homed servers. Running multi-homed servers in a case where you would certainly need to understand and work with a local Windows routing table. So let's start here. If you think this doesn't apply to you because you've never heard of multi-homed before, think again. Multi-homed is just a funny looking word, meaning your server has more than one NIC, which means network interface card. This could certainly be the case for you. Even if you are a small shop that doesn't have a lot of servers, many times small business or essential servers have made multiple network interfaces separating internal traffic from internet traffic. Another instance of a multi-home server would be a remote access server that provides direct access, VPN, or proxy capabilities at the edge of your network. Yet another reason to be interested and understand multi-homing is Hyper-V servers. It is very common for Hyper-V servers to have multiple NICs because the VMs that are running on that server might need to tap into different physical networks within your organization. Now that we have established what a multi-homed server is, simply one has more than a single network card. You might still be wondering why we are discussing this. If you have more than one NIC, don't I simply configure each NIC individually inside Windows, giving each one an IP address like I would for any NIC on any server? Yes and no. Yes, you configure an IP address on each NIC because it needs that for identification and transport of packets on the network. No, you do not need you do not set up all of the NICs on your server in the same way. There is one critical item that you need to keep in mind and adhere to in order to make traffic flow work properly on your multi-home server. Only one default gateway. This is the golden ticket. When you multi-home a server by having multiple NICs, you can only have one default gateway, one for your entire server. This means you will have one NIC with a default gateway and one or many NICs that do not have a default gateway inside their TCP IP settings. This is extremely important. The purpose of a default gateway is to be the path of last resort. When Windows wants to send a packet to a destination, it browses over the local routing table. Yes, there is a routing table, even if you haven't configured it or ever looked at it, and checks to see whether or not a specific static route exists for the destination subnet where this packet needs to go. If a route exists, it shoots the packet out that route and network interface to the destination. If no static route exists in the routing table, then it falls back onto using the default gateway and sends the traffic to that default gateway address. On all single NIC servers, the default gateway is a router that is assigned with all of the routing information for your network. And so the server simply hands it to the router and the router does the rest of the work. When we have multiple NICs on a Windows server, we cannot give each one a default gateway because it will majorly confuse traffic flow from your server. It would be a crapshoot as to which default gateway traffic flows towards with every network transmission. I have helped many people troubleshoot servers in the field with exactly this problem. They need to use their server as a bridge between two networks, or to have the server plugged in to multiple different networks for whatever the reason, and are now struggling because sometimes traffic seems to work and sometimes it doesn't. We start looking through the NIC properties, discover that every NIC has its own default gateway address in the TCP/IP properties. Bingo, that's our problem. The system is completely confused when it tries to send out traffic because it doesn't know which gateway it needs to use at what times. If you have ever tried adding default gateways to more than one NIC on the same server, you will probably be familiar with the warning prompt that is displayed when you do this. Let's give it a try. I have added another NIC to one of my servers and have IP settings configured on just one of the NICs. Now I will add a new IP address, subnet mask, and default gateway onto my second NIC. When I click on the OK button to save those changes, I am presented with the following message. This is one of those warnings that is easy to misread because of its slightly cryptic nature, but you get the essence of it. Proceed at your own risk. And then what to do, and then what do most admins do at this point? Simply click through it and save the changes anyway. Then the routing problems start. Maybe not today, but perhaps the next time you reboot the server, or maybe 3 weeks down the road. But at some point, your server will start to send packets to the wrong destinations and cause you trouble. Building a route. So what is our answer to all of this? Build a static routing table when you have multiple NICs on a server, thereby making it multi-homed. You must tell Windows which NIC to use for what traffic inside the routing table. This way, when network traffic needs to leave the server for a particular destination, the routing table is aware of the different directions and paths that the traffic will need to take in order to get there, and send it out accordingly. You will still be relying on the routers to take the traffic the rest of the way, but getting the packets to the correct router by sending them out the proper physical NIC is key to making sure that traffic flows quickly and appropriately from your multi-home server. Now that we understand why the routing table is important and conceptually how we need to use it, let's dig in and add a couple of routes on my dual NIC server. We will add a route using command prompt, and we will also add one using PowerShell, since you can do so from either platforms, but the syntax used is different depending on which you prefer. Adding a route with command prompt. Before we can plan our new route, we need to get the lay of the land for the current networking configuration on this server. It has two NICs. One is plugged into my internal network and one is plugged into my DMZ that faces out towards the internet. Since I can only have one default gateway address, it goes onto the DMZ NIC because there is no way that I could add routes for every subnet that might need to be contacted over the internet. By putting the default gateway on my DMZ NIC, this means that the internal NIC does not have a default gateway and is very limited in what it can contact at the moment. The internal subnet that I am physically plugged into is 10.0.0.0/24. So I can currently contact anything in this small portion network between 10.0.0.1 through 10.0.0.254, but I cannot contact anything else at the moment through my internal NIC because the routing table knows nothing about the other subnets that I have inside my internal network. I have an additional I have an additional subnet that is 192.168.04/24, and there are some servers running within this subnet that I need to be able to contact from this new server. Here is a general syntax of the route statement we need to follow in order to make this traffic flow from our server into the new subnet. Route add p subnet ID mask subnet mask gateway if interface ID. Before we can type out our unique route statement for adding the 192.168 network, we need to do a little detective work and figure out what we are going to use in these fields. Here is a breakdown of the parts and pieces that are required to build a route statement. -p, the dash -p makes this command persistent. If you forgot to put -p in the route add statement, this new route will disappear the next time you reboot your server. Subnet ID. This is a subnet we are adding. In our case, it is 192.168.16.0. Subnet mask. This is the subnet mask number for the new route, 255.255.255.0 gateway. This one is a little confusing. It is very common to mistakenly think it means you need to enter the gateway address for the new subnet, but that would be incorrect. What you are actually defining here is the first hop that the server needs to hit in order to send out this traffic, or in other words, if you had configured the default gateway address on the internal NIC, what would that address be for? Our network, it is 10.0.0.1 interface ID. Specifying an interface ID number is not entirely necessary to create a route, but if you do not specify it, there is a potential that your route could bind itself to the wrong NIC and send traffic out the wrong direction. I've seen it happen before, so I always specify a network interface ID number. This is typically a 1 or 2-digit number that is the Windows identifier for that internal NIC itself. We can figure out what the interface number is by looking at the route print command. At the top of the route print, you will see all of the NICs in a system listed. In our case, the internal NIC is at the top in the list, and you can see it is the interface ID number 4. So in my route add statement, I'm going to use if 4 at the end of my statement to make sure my new route binds itself to the physical NIC. Here is our completed route add statement. Route add -p 192.168.16.0 mask 255.255.255.0 10.0.0.1 F4. Still at command prompt. If you now run our route print command, you can see our new 192.168.0 route listed in the persistent route section of the routing table, and we can now send packets into that subnet from this new server. Deleting a route. Occasionally you may key in a route statement incorrectly. The best way to handle this is to simply delete a bad route and then rerun your route add statement with the correct syntax. There are possibly other reasons why you might need to delete routes every now and then, so you'll want to be familiar with this command. Deleting routes is much simpler than adding new ones. All you need to know is the subnet ID for the route you want to remove. That's it. Then simply route delete subnet ID, for example, to get rid of our 192.168.16.0 route that we created earlier. While we are working inside command prompt, I would simply issue this command: route delete 192.168.16.0, adding a route with PowerShell. Since PowerShell is kind of king when it comes to most command line orientated tasks inside Windows Server, we ought to accomplish the same mission from this interface as well. You can utilize the same route at command from inside the PowerShell prompt. That will work just fine, but there is also a specialized CMD LET that we can use instead. Let's utilize new net route to add yet another subnet to our routing table. This time we're going to add 192.168.17.0. Here is a command we can utilize: new route, destination prefix 192.168.17.0 / 24, interface index 4, next hop 10.0.0.1. You can see that the structure is similar but a little friendlier. Instead of having to type the word mask and specify the whole subnet mask number, you can use the slash method for identifying the subnet mask within the same identifier. Also, before we were specifying the gateway, which is always a little confusing. With the new net route CMD let we instead specify what is called the next hop. This makes a little bit more sense to me, and which we previously utilized route printed in order to see our full routing table. The PowerShell CMD let to display that table for use is simply get net route : so I'm going to leave this video here for today. If you like listening, please consider like, sharing, and subscribing. Thank you.